Rotations. This lesson is based upon the Mississippi College and Career Readiness Standards. We will study the properties of rotations. We'll discuss how rotations are congruent transformations, how their lines and angles are congruent, meaning that they have the same size and will maintain the same shape. We will also describe the effects of rotations on two-dimensional figures using coordinates. So, what are rotations? A rotation is a transformation where you turn a figure about a given point. The amount of rotation is called the angle of rotation and is measured in degrees. Real life examples of rotations. First, we have strumming a guitar. Next, we see a hammer hitting a nail. Now we see track runners running on a track. And another example is the agitation of a washing machine. Next, we have a Ferris wheel that's turning in a rotational pattern. Last but not least, we see the opening and the closing of your heart valves to control blood flow in a rotational pattern. Reviewing the coordinate plane. In order to understand rotations, you would have to consider the quadrants in the coordinate plane. Quadrant 1, you'll see that the x and the y coordinates are both positive. In quadrant 2, you'll see where the x coordinate is negative and the y coordinate is positive. In quadrant 3, you'll notice that both the x and the y coordinates are both negative. In quadrant 4, you'll see that the x is always positive and the y coordinate is negative. Counterclockwise rotations. Counterclockwise rotations rotate in the opposite direction that a normal clock goes. If your problem calls for one quadrant turn, it's usually a 90-degree rotation. A 180-degree rotation represents 2 quadrant turns, and a 270-degree rotation represents 3 quadrant turns. Last but not least, 360-degree rotations represent 4 quadrant turns. In steps to rotate an image, you would ask yourself the following questions. 1, in what quadrant is the given point located? 2, how many degrees am I asked to rotate it? Clockwise or counterclockwise? 3, in which quadrant will the new point land? 4, what are the signs for this particular quadrant? In considering these points, we will look at the degrees of rotations. For 90-degree rotations, take note of the steps from 3 and 4. Take note of the signs, and then you'll switch the order of the x and y values. For 180-degree rotations, you keep the ordered pair just as it is. You'll just only do the opposite signs for both the x and the y coordinates. For 270-degree rotations, you'll take note of the signs from step 3 and 4. And then take note of it and switch the order of the x and y values. Finally, for 360-degree rotations, it's the exact same. Ordered pair. You are back where you started. Now, let's work a few examples of counterclockwise rotations. All right, so let's take a look. We have 8.3 rotations practice, and we are doing counterclockwise rotations. That means that, like a normal clock, which rotates to the right, counterclockwise rotations actually rotate toward the left. All right, so the directions read, find the coordinates of the vertices of each figure after the given transformation. Number one, we have a rotation that's 90 degrees counterclockwise about the origin. So counterclockwise rotations. If we take a look at the notes, so let's follow the 6 steps or the 4 steps that were given from the presentation. Step 1 says, in what quadrant is the given point located? The given point is point C. It is located in quadrant 3, and the coordinates are -1, -2. Step 2X, how many degrees are we asked to rotate it? We're asked to rotate it 90 degrees counterclockwise. So we will do 1 quadrant turn. Step 3X, in which quadrant will the new point land? With a 90 degree counterclockwise turn, that means we're going to do 1 turn. And it's going to land in quadrant 4. We're going to go ahead and take note of that. So for our final answer, we'll already know that our answer will be in quadrant 4. And then it says, number 4, what are the signs for this particular quadrant? In quadrant 4, the X values are positive and the Y values are negative. Then in the table, it says degrees of rotation. For 90 degree rotations, take note of the signs from steps 3 and 4. We've done that. Then it says switch the order of the X and Y. So here for point C, we have -1, -2. If we take all the signs off and just change the order, here we have 1 and 2, so we can change it to 2 and 1. Now, for our final answer, for C prime, we have +2, -1 as our new coordinate. Here is C prime. Alright, so let's take a look at example 2. We have point H, which is in quadrant 4, and that point is +3, and the Y value is -4. Alright, so it's located in quadrant 4, and we're going to do 2 counterclockwise quadrant turns. So this is 1 quadrant turn, 2 quadrant turns. So our final answer will land in quadrant 2. And we know that in quadrant 2, the X's are negative and the Y values are positive. Now, if we take a look on our chart, our degrees of rotation chart, it tells us that for 180 degree rotations, keep the ordered pair. So this 3, 4, we will keep the ordered pair, and we'll just do the opposite of both the X and the Y coordinates. So the opposite of 3 is -3. Well, our negative sign is already there. We'll just write 3. That makes it -3. And the opposite of -4 is +4. So our final answer is H prime is -3, +4. Alright, as we continue along, number 3 is a rotation 270 degrees counterclockwise about the origin. So there is point Y. The ordered pair for point Y is X is +5, Y is -2. So we're asked to do a 270 degree counterclockwise rotations. That's 3 quadrant turns. So in order to do this rotation, let's go counterclockwise. Here's 1 turn, 2 turns, and 3 turns. So we know our final answer will be in quadrant 3. And the signs for quadrant 3 are negative, negative. Let's look at our degrees of rotation chart. It says for 270-degree rotations, take note of the signs from steps 3 and 4 and switch the order of the X and Y. So we'll take all of the signs off and just switch the order. Since that's 5 and 2, we'll switch it to 2 and 5. Therefore, our final answer is -2, -5. Here's our Y prime. Alright, last but not least, we have a number 4, rotation 300 degrees about the origin. Okay, so we have point D. The order pair for point D is -2, +2. It's located in quadrant 2. Now we know that with 360 degrees, that's 4 quadrant turns. So as we turn, 1, 2 turns, 3 turns, 4 turns. If we take a look at quadrant 4, X is negative, Y is positive. Our degrees of rotation chart says for 360-degree rotations, it's the same ordered pair. You are back where you started. So we will have the exact same ordered pair. X is still -2 and Y is still +2. It's the exact same ordered pair. So we'll just place a dot right over that regular D and make sure we write D prime. And there you have an example of a 90-degree counterclockwise rotation, 180-degree counterclockwise rotation, a 270-degree counterclockwise rotation, and a 360-degree counterclockwise rotation.